Hi guys, in this video presented by the student of Instituto Tecnológico Superior de Comalcalco of the Card of Mechatronic Engineering, we are going to present the following topics. First one, computer-aided manufacturing. Two, computer-aided design and manufacturing applications, flexible manufacturing system, and manufacturing cells.
Well, let's start by defining what CAM is. CAD/CAM, computer-aided and design and computer-aided manufacturing, refers to software used to design and manufacture products. CAD involves using computer technologies for design and design documentation. CAD/CAM applications are used to design a product and program manufacturing process, especially CNC machines. CAM system can maximize the utilization of the wide range of the production equipment, including high speed, 5-axis, multifunctional and turning machines, electric desert machines, and CMA equipment inspection. It commonly refers to the use of computer numerical control (MC) software application to create detailed heat code instruction that drive machine tools for manufacturing parts controlled numerically by computer. CAM software uses the models and assemblers created in CAD software to generate trajectories of tools that direct the machine responsible for converting designs into physical pieces. CAD/CAM software is generally used for machine prototypes and finished parts. Stage of CAM, computer-assisted manufacturing. And the user selects the intent previews, draft the constituent and piece of product, enters the cutting parameters, free date, rotation speed of the cutting element, depth of cut of others. Performs the simulation of the machine process, carries out the post-processing and translation of the simulation into the language of the specific numerical control machines. It automatically obtains the numerical control program which transmitted to the CNC machine by means of the magnetic medium or by the network of the system for the right machine of the piece. It is necessary to know the difference between CAD, CAM, and CAD/CAM software. In CAD software, only one piece or set is driven or designed for printing for archivate for later use in CAM or CAD/CAM software.
Hello, my name is Sebastian Ramos Escalante. When we talk about design and manufacturing, the first thing that cross our mind are CAD and CAM design software. But what do these terms mean? CAD is computer-aided drawing and CAM is computer-aided manufacturing. These two systems are helping us to perform design and machining with greater ease and versatility through automation. CAD is of great importance because without it, the process of computer-aided manufacturing could not be realized. The design through CAD software is an easy and complex task, since it is necessary to know the different tools that the different software offers. Even so, the creation of polygons and 2D shapes is easy to understand due to the tools for creating lines, rectangles, circles, etc., and the line cutting tools to reach a final form. The main CAD software are AutoCAD, SolidWorks, and the FreeCAD. These three have different tools that are totally similar and easy to use. In the case of AutoCAD, is oriented to the area of architecture, facilitating the drawing of plans and the obtaining of measurement in 2D. SolidWorks is a software designed for easy creation of engineering mechanisms and convert 2 drawings to solid objects in 3D. FreeCAD is similar to SolidWorks, with the only difference to be free software. The CAM design software is used to generate machining trajectory based on a CAD design. This means that we can manufacture any CAM design. There are several automated machines that specialize in manufacturing. It is CNC mills, CNC lathes, 3D printers, etc. The most used software for this purpose are Fusion 360 and Mastercam. Let's talk about CAM. The machining of parts based on a CAD design is one of the main characteristics of this type of software, since it allows us to perform machining in less time than in no automated machine. Generate the code of the movements that the machine will perform by coordinates in the particular it's to admire. The ability to configure the cutting tools and the total area of the piece to be machined to perform the precise and necessary movements to obtain a finished product is one of the greatest facilities that the software offers. In the same way, it allows us to make compensation to avoid collision of the machine and leave excess material for a final finish. Compensation also serves to prevent the bad end of a piece caused by the wastage of the cutting tools. Similarly, calculates to reduce or increase the speed of progress to improve the finish of piece and reduce the machining time.
Here we define the concept of flexible manufacturing system through its 3 main characteristics. First, has a group of workstations interconnected by means of a transport system. Number 2, you must to expect that the transportation system as well as other storage systems that integrated must be automatic. So that's finally the whole is controlled by a computer. The FMS replace or try to replace the rigid production system, as well as the transfer machines or the dedicated production plants. Although sometimes they are combined, but as long as you add the character of an FMS. The FMS can be classified according to the degree of automation and sophistication of their control system labels. Machine tools with numerical control, CNC, transfer, cell, or flexible manufacturing cells. Flexible manufacturing line, fully automated factory. As we can see, they depend all on the degree of automation, going through a level where only numerical control machines are included. Inside, we see a factory that's called manufacturing either 24 hours a day. The FMS serves to manufacture a family of parts. A family of pieces is composed of different pieces from each other, but they have similarities in geometric shape and size or in the manufacturing process, having as a basic composite piece, which is like a main design that's allowed to determine if it is a possible manufacture all the pieces of a certain family. In a FMs, there must be 3 fundamental parts that must be divided into subsets, which are described below. Primary elements, CNC machines of any kind, center of turning, machine, grinding, EDM. Elements for auxiliary operation, lubricant, washer, treatment ovens, automatic measuring system, and painting station, chrome plating, coating, assembling station for parts, welding, screwing, riveting, and the secondary elements, loading and unloading areas for parts and tools, transport system between station, robots for pick and place of parts, transport system based on pallets. And the ultimate level is the software. That is necessary to have software that manage all machines, transport system, and others. A manufacturing cell must meet the following demands: maintain a continuous flow of material in process and minimize delays and inventories. Part consists of grouping the machines into cells based on the similarities in design and manufacturing process of the parts they process, which make up the families of parts. In this way, each family is assigned a manufacturing cells. Types of cells. Flexible manufacturing cells. In view of the rapid change in market demand and the need for more variety of product in smaller quantities, the flexibility of manufacturing operation is very convenient. Manufacturing cells can become flexible by incorporating machines and machine centers with computerized numerical control, and by industrial robots or other mechanics materials handling system. In general, flexible manufacturing cells are not attended by humans, so their design and operation must be more precise than those of other cells. The selection of the machine and robots, including the type and capacity of final effector and their control system, are important to have a correct operation of the cell. The probability of an appreciable change in the demand of families of parts must be considered during the design to ensure that the equipment involved has the correct flexibility and capacity. U manufacturing cells. It is an arrangement of people, machine, materials, and method with the step of the process placed next to each other through which the parts are processed in a continuous flow in sequential order through which the parts are processed in a continuous flow, normally in the form of U, that allows the flows of a single piece and the allocation of personnel inflexible with through the concept of multi-skills. To reduce processing time and use of resources, it is about carrying out operation using time, for which it is necessary to change the traditional arrangement of similar machine grouped in process departments, the current milling turning, to manufacturing cells in U-shape, integrating the machine personnel with multiple skills, tools, spare parts, materials, components, and facilities necessary to manufacture a family of products per cell through groups technology. Simulation of manufacturing cells. The simulation of a flexible manufacturing cells includes the modeling of electromechanical elements which allow to analyze the problem of difficult solution in the behavior for the component of the manufacturing cells, such as the following: flexibility, reconfigurability, fault tolerance. We have a conclusion and observation. It can be seen that the manufacturing cell is built by various manufacturing elements, ranging from conveyor belts, robotic arms, the business planning, where the viability of the piece to be manufactured and its viability in this type of construction must be analyzed. So a manufacturing cell also becomes a flexible system where the design of part, control of machine, and total control of the process will be borne by a computer operated by human, and even without the need for the operator to be present. That's all. Thank you.